Okay, let's have a class. We did the full biochemistry test. Today we'll continue to do that. But let's go over the results. Okay, what's the results we looked about? So the first test what we did is SIM test. So SIM test, remind yourself what they are talking about. What is this? Sulfide. And how do you know sulfide test is positive? Do you know why it is positive? Black, you can see it. It's okay. Turns black. And remember, the test what we did is needle stab inoculation, right in the middle. So let's see what you have. Who has E. coli? Who has Citrobacter? Very good. That's good. So, sulfide, can you see what's the difference between these two? Which one is positive?
Citrobacter.
That's very obvious. So, the first results you can see is Citrobacter is positive and E. coli is negative. Okay, that's the first thing. Okay, second test, we talk about the Indo. And you need to know that is a byproduct of tryptophan. How did we test it? You're not going to see it right now. What we need to do is we need to add a big reagent, a big drop of the reagent called Kovac. So let's do that to see what's happening. Okay? So I'm going to add a Kovac. Now always remember you have to shake. And then let's add to the E. coli side to see what it looks like. Did you see cherry red? A little bit. Not really. Okay, let's add a little bit more. Maybe this is older. That happens all the time. Well, it started showing up a little bit. Let's say it's dark red, not cherry red. Used to be very beautiful. Now, by the way, you can see E. coli usually in the middle line. See the big chunk of cluster in the middle line? It started to turn a little bit. Fake cherry red. Okay. So, we can say this is E. coli showing you cherry red color. It is positive. And this is motility, which is no motility. Okay. Now, how about this guy? You can see it goes everywhere, especially like a black one. It's already surrounded the tube, and you can see the bottom. It goes everywhere. So, it is motility standpoints. Citrobacter, it is positive, and E. coli, negative. Okay, that's SIM test. We just go over it real quick. You guys can go ahead to do by yourself later on. Okay, I just keep these reagents here if you wanted to do. It might be a little older, so the results won't be very obvious. But you can see, start to see some red. You can see some red there. Start to show up, you can see. Right here. See? A little bit. Fake cherry red. Not looks like a cherry, maybe like a, what do you say? Like a some like a vanilla latte from some red wines maybe, a little color like that. But that looks good. Citrobacter looks good. So, okay, that's the first test. Second test, what we have? Phenylalanine deaminase test. So what we should do? You have a slant. Remember? Zigzag. Okay, let's get a slant. E. coli and Citrobacter. Let's get Citrobacter. Simple. Let's get the E. coli also. Okay, first of all, it has to grow. Do you have a zigzag of a big smear on the slant? Like these two gentlemen did. If you don't have a zigzag slant, then we cannot go over it. Which means you didn't inoculate. So first of all, you have a zigzag marker. Second, we also need to add something there. What is this called? Ferric chloride. Once you add a ferric chloride, ideally it should be turned dark green color, which means deaminase. Pyruvate created a phenylpyruvate. Phenylalanine take out of the amino group, become a phenylpyruvate. So let's do an experiment. We have Citrobacter, and we also have an E. coli. It's already grown. Let's see it's positive or negative. So ferric chloride. We need to find it. Where are the ferric chloride? Okay, we had a ferric chloride. So what we do, we're going to add it to see what happens. So we had a couple of drops there. Hopefully the results are good. Sometimes not good. Sometimes the results are terrible. Because of the bacteria or because of the reagent. Maybe no difference. Used to be have a big difference. We'll see. So what is this one? Citra. What is LF? That looks not very dark. Not really. What we find here is both of these are negative. Ideally, one of them should be positive. So I just want to tell you, Proteus vulgaris is positive, but we can't do it. Here we have a negative, that's fine. Negative is negative. We respect our results. It could be Citrobacter contaminated with E. coli, or Citrobacter is not a Citrobacter, or it could be the reagent is being old. Okay, so what we get here is negative. That's fine. We accept our results, but I'll tell you, Proteus vulgaris, a soil pathogen, is positive. That's theoretical. And you can do it. Maybe trying a different reagent, we'll see what it looks like. Okay? Number 3, oxidase test. So how we did it? We add E. coli, we add Citrobacter. Okay, we're gonna dump in the oxidase reagent. So let's see what it looks like. Who has a plate? Well, I'll borrow yours to see whether this works. So oxidase reagent, we are going to have an oxidase reagent right here. Hope it's still working. So we add a couple of that, couple of here. React it a little bit to see anything turns like Any of these turns like what we say, purple? Looks like it's not very purple. Slightly. Tiny, slightly. See? Slightly purple. From the citrobacter part, slightly purple. Okay, let's try another one. Give it back. You can wait a little bit. Who has other plates? Just have other plates. That's okay. We'll try another one. Oxidase reagent. We'll see whether that works. So you can see that the citrobacter seems like it started to turn in the purple color, but it's not very obvious. You can see it slightly. So that's why this is not a very good surrogate. But you can see it. It starts to have the line comes out. The best one is Pseudomonas. You can start to see it a little bit. See? That's not really. You see? See? Start to see it. Start to show up. I'll use that one. You guys can see citrobacter side start to show up. Can you see it? Yeah. Can you see it? So start to show it, but not very ideal. That's why I said that surrogate, compared to original Pseudomonas, they always have something which is debatable. What is a good surrogate? And then if you stay another 30 minutes, this started going to be showing you false positive because the oxygen is coming. Okay, so these things better we using the original culture, but we don't have it. So this I will say positive, this is negative, and after 1 minute it's both positive because it's exposed to the oxygen. But ideally, Pseudomonas, it should be positive. And we said enterobacteria ACA is negative. Okay, last one. Okay, this experiment you have to do by yourself. What you do? You come here to get an empty tube, and you dump them in the half. So let's say I'll give you an example. Okay, let's just have a one tube. Yeah. So let's say this is a tube. We are doing for methyl red and Vogus Preskia test. What we do is we dump them into half. Okay, we dump them into half. Like this. And then one tube to do the methyl red test. So let's have a methyl red. So we need to find it which one has a methyl red. Brief slightly has some. One is find the tube has methyl red. That's oxidase. We should have let me see whether this one still have methyl red. Okay, one of them you're gonna add a methyl red. If it doesn't have it, then it's gone. Let's focus plus the region A. Region B. I'll find it for you. One of them you need to add a methyl red. The other one you add a Preskia test. Proskia reagent, we have A and B. So we have A here, and we need to find the Proskia test B. Okay, so the B is right here. So let's do that. So we add a couple of drops of A. Couple of drops of B. Oh, that's really bad. That's ideally should be showing you red color after incubation like 5 minutes. And this one you can add methyl red, it shouldn't be showing anything. Then showing you positive and negative. But that reagent is a little old. But ideally this should be red, and that should be colorless. So you can just write your ideal results here. Okay, I have 2 tubes. This is for methyl red. The other one you add a reagent A and B for the VP test. Now for E. coli, what you should do, you should see the methyl red is positive. So E. coli methyl red is positive, VP is negative. And for Enterobacter, and this is negative and this is positive. Ideally is like that. I'll find a reagent for you. If you guys are interested, you can do it. And some of these are still here. And if you're interested, you can do it. And the ferric chloride is right here, Kovac is right here, and the Vogel's Proskia test is here. And I think I'll find the methyl red reagent for you. That doesn't have much. They still have a little bit methyl red here, so let me just do a quick test to see the methyl red what it looks like. Luckily, this looks okay. That's red. That's E. coli. And that is colorless. Remember, I added Proskia, Vogel's Proskia test reagent A and B. It doesn't show up anything. So you can do that. I have 72 tubes. And you guys can work with your bench partner to do it. Methyl red test is right here. Okay? Reagent Vogel's reagent B is here, and Vogel's test reagent BA is right here. And this for Kovac, for the Indo test, and we also had a ferric chloride for the deaminase test, and I also had a oxidase reagents right here. Okay, but I strongly suggest you can do the MRVP test right here. That's a reagent you can have it. You don't have to do everybody do. I only have 72 tubes, so just grab a couple. 4 of you as a group, just do a demonstration. 2 of you as a group, just do a demonstration. Okay? Because today's other work are relatively simple. So this test, you could do it later on by yourself. The results I already tell you. And the VP, you have to incubate a little bit. You can put on your tray in the rack, wait for Thursday to see whether there's a color change. Okay, I suggest one bench, have 2 people do it. Then show the other students on Thursday what it looks like. Methyl red you can see immediately. Okay, let's move to today's work. What we're going to do today is relatively easy, but something we want to mention. So bacteria can use sugar, which is carbohydrates, as an energy resource, but they also can use other, we call it other material, molecular, macromolecular as an energy resource if they have enzymatic function. So we say enzymatic test. First of all, we have one agar. Looks like this. A little bit blue. Well, by the way, I don't think this makes very well, but it's okay. You can use. They're called split blue agar. This is for bacteria can testing whether they can use fatty acids. Okay, what are fatty acids? Remember these? Is that right? Fatty acids? What you have? What is this? Stearic acids? Palmitic acids? What is that? That's palmitic acids, 16-0. Okay. What is that? Stearic acid. Then what is that? Linoleic acids, linolenic acids. Linolenic acids and the linolenic acid. So one double bonds, two double bonds. And then we also could have